Okay, welcome back. We're talking about the network address translation. So almost all home routers that I know of use NAT. In other words, you get one IP address from the internet service provider, which is a real IP address. It's attached to the internet, so it's a legitimate one. And all the machines you have on the inside get given fake IP addresses, and they get translated. When they hit the router, they take this fake one and turn it into a real one. So let me just give you an example. I'm running NAT right now. So if I go in here and type IP config, and so it says my IP address is 10.02.15. Okay, I happen to know that the 10 range is what's called a private address, so it's not a real address. It won't work on the internet at all. But if I go over here and say, what is my IP address? It tells me my real IP address is 70.117.153.83. So it got translated from 10.02.15 to this, and all packets coming in get translated back and go back in the other direction. So it kind of makes sense. By the way, NAT was really designed to solve a problem when we were running out of IP addresses. Before this, you really had to have, if you had 100 machines, you had to have 100 unique IP addresses. Well, that's not going to work. So at the university, for example, I'm making these numbers up. Let's say we have, 500 computers in the university. Does that mean we have 500 unique IP addresses that we can assign to those guys? No, we got a handful. Okay. Now we have a big range. That way we don't all have to be competing for a single IP address. But still, a heck of a lot less than 500 of them. Okay, making sense? All right, let me continue. All right, so selecting the right firewall, page 317. So it's kind of a balance between the protection that this thing provides. This is a good one, and it's resilient. But yeah, there's cost and complexity. You might have to hire somebody to set this up, to set up the filtering rules for the external, because they're not going to be the same. And by the way, let me just give you an example of one of the rules. So my internal IP address is either 192.168 or 10.10. I can't tell from this diagram because this diagram's horrible. Let's assume it's 10.10. All right. I say, look, if somebody is coming in and hits this and they're using one of my IP addresses that I own, right? My real IP addresses, they're coming in from the internet pretending to be me. I'm going to look at that packet and say, look, that's one of my IP addresses, and you're coming in from the outside. There's no way in heck I'm going to let you through. So isn't that kind of a cool rule? No, this guy knows what your external IP addresses really are. Okay, and they all ought to be coming from the right-hand side, not from the left-hand side. Okay, it does take skills to do this and requires specialized training. You wouldn't want to grab some intern and say, "Hey, configure the firewall." It's like, nah. Okay, configuring and maintaining. So configuration rules are very complex, and they have to be carefully created and tested. I mean, for example, all it takes is to put like that deny, put it in the wrong order, and you've blown things up. So best practices is you could, for outgoing traffic, you can allow all to start with, and then deny the things you don't want. That would be good from going from trusted to untrusted. On the other hand, for incoming, it's deny everything and allow only these things. For example, the Army, I'm making these numbers up because I don't know. There's probably like 5 protocols they allow, HTTP, HTTPS, email. And that's maybe some other little thing, DNS. That's probably it. Nothing else. Okay. And then no remote management. In other words, typically, people on the inside are allowed to go to this router and make tweaks. But you can't do that at home. You can't be on the untrusted side and hit this router and say, I'm going to log into the admin and I'm going to do... No, of course not. You can't do any remote kind of management. So firewall rules, and there's multiple rule sets. You don't just have to have one. You could have a gazillion of these things. And these are what's called the well-known port numbers. I'm not asking you to memorize these things. Some of these things are ancient. 20 and 21 or FTP, that's rarely used these days, but it's still around. Telnet typically has been supplanted with Secure Shell. Simple mail transport, that's still around. DNS, that's still around. Port 80, that's been around. They're still around. SNMP, Hypertext, those guys. Okay. And so these guys are, remember the rule set we talked about? You have to have like the deny first and all these things. Okay. And they've done it in order because you could have a conflict resolution. I can say, I don't want any telnet going out, for example. And then I go to Bob and I say, well, except for Bob's machine. If you're on Bob's machine, you are allowed to use telnet or FTP. In other words, not everyone in the organization can FTP to an outside server, but Bob's machine can. Now, in a next generation firewall, you can actually put it by person. Regular firewall, they don't have any idea who's doing it. It's just machines. But next generation, you can make it a little bit more better. So content filters. Now, technically, this is not really a firewall function, although, a lot of the newer ones do. We're talking about like proxy server filtering. And so I could create a whitelist of those sites that are allowed, or conversely, a blacklist to limit those things. So you can't go to a gambling site. You can't go to a porn site. You can't go to, maybe a streaming service. You're not allowed to go to Netflix, from inside the company, those kinds of things. So, the cool part about this is when you buy a firewall, proxy server filtering, whatever this thing is I'm just talking about, you don't necessarily have to set this exception list up on your own. The company will provide it to you. They'll maintain, what is a gambling site, what is a streaming service, what's a porn site. You don't have to do that. Thank goodness. Okay. So now we're talking about remote connections, page 325. So particularly during COVID, a lot of people started working from home. And so you had to have a way to connect to the private network without tripping any alarms, so to speak. I need to be able to get from here all the way in. So one of the things that you should add to the list of things that belong to the DMZ is a VPN gateway. Something that says, I'm doing authentication, I see you're good, and I'll pass you along. Okay. So for remote access, I basically need a different kind of authentication. I can't just use the same thing you do over here. Over here, I can have like a hardware token or a card. You put in a card reader, those kind of things. I can't do that at home necessarily, unless you want to have at the expense of everyone buying a card reader. So Radius, remote authentication dial-in service, yeah, it's that old, but no one uses dial-up. But Radius was a great idea, and it's still being used. So Radius is just a technique that basically says, here's how we do this. A remote worker dials in, okay, and submits her human name password. The thing passes the user back to a Radius server. A Radius service provides or rejects based upon its authorization. In other words, for example, not everyone is allowed to remote in, right? So that was this network access thing could say, well, yes, you have legitimate credentials. Yes, you provided me your name and password, but you're not on the list of people who can do this remotely. So that kind of thing. And so, anyway, that's just one of the things it can do. Kerberos is another one. If you're into Greek mythology, Kerberos is the three-headed dog that guards the gates of hell. Right? So, and it's basically it's used by Microsoft internally. For example, Microsoft Windows uses Kerberos to do this authentication to the Active Directory server. And it's based upon the use of private keys, which we haven't got to yet. So just nod your head like you know what I'm talking about. And then Sesame, which basically is the European equivalent of the same thing. So let's talk about something that's not in the book. It's called Network Access Protection. Now, this is a Microsoft thing, okay? And it's kind of cool. Here's how it works. I'm on a laptop. It could be a private laptop or it could be a company-provided laptop. When I go in, it first goes through and checks and then puts me in like a holding area and says, hang on a second, let's check you out. First of all, do you have all the patches? Oh, you don't? If you get sent off to a remediation server, you can't do anything else, but the remediation server is going to say, okay, wait a minute, here's the patches you need to install, and here's the virus signatures that need to be updated. So if you had a laptop that was a company issue, but you had it turned off for a month, and finally you turned it on, this will provide that what potentially is a dirty machine from getting all the way in, because there's a vulnerability on your machine because it's been off for a couple of months. So this puts you in a holding area. They check you out, make sure you got all your patches, make sure you got all the virus signatures, and then you move on. So this policy server, this is where the patch and antivirus stuff, and then you get on to, the restricted network. Okay, kind of makes sense. So I kind of like this. You get siloed off until you've accomplished the remediation that's required. And then after you've been cleaned, then you can allow it in. I don't know why this isn't all that prevalent. Obviously, it's a Microsoft thing, but I still don't get it. Okay, virtual private network. So a private network that uses the public infrastructure. Now, there's two types. From my house, going to a business probably is going to be providing software provided by the business. Some sort of Cisco thing, or some sort of Palo Alto software that I install on my machine that has very secure keys back and forth and allows me to connect. So that's one type. And when I use this, called tunneling, when I do this, when I'm connecting in, my IP address changes because I'm now just as if I'm on the inside. Okay. When I get in, I am definitely over here in this section. It just makes it look like I'm over here. So I get an IP address assigned over here. Okay. And then another type is between a hardwired connection. This is not like a temporary thing like I just described. I have one business, but they're separated by, they have field offices in 3 other states. So in the old days, you would buy a leased line, for the telephone company to make these connections. That's too expensive. Now we just use VPN, where we tunnel in over the internet, but this is a permanent connection. It's not something you temporarily go through. So you have most likely hardware-based thing over here and a hardware-based thing over here, and they talk to each other. So it makes it look like you're all one happy network, but you're actually tunneling through the network. Okay. So here's what these things could do. So encapsulation basically takes incoming data or outgoing data in whatever the native protocol is, and then wraps it into something else so you can send it off. Encryption, which obviously means no one can see what's going on, and then authentication because, I need to prove I am who I say I am. Okay, so the transport mode, I'm trying to use these terms kind of sort of. So I'm on my machine, and I need to be able to encrypt data so when I go across the untrusted network and hit this VPN server, then no one can see what's going on. Okay, and then once it gets this guy, then it just dumps me on. Let me explain that. Is it encrypted going across the internet? Yes. But when it gets to here, it no longer needs to be encrypted. So it breaks the encryption, dumps me onto the secure side of the network. Okay? I don't need to be encrypted the entire way just till I get to that box. And after that, I'm okay. So it's just that I'm trying to tunnel through the untrusted network. Okay. So this is typically a temporary thing, right? Temporary thing, only when needed. And the packets are encrypted, but not necessarily the headers. I don't need the headers to be encrypted because I still need to have this thing routed from, this my ISP to this, the node. So I can't afford to encrypt everything. The source and IP addresses have to still be there. Okay, makes sense? Okay. And so this is kind of sort of significant. Now in the tunnel mode, is permanent hardwired kind of a thing. So I have a dedicated VPN server and it could do everything. It can encrypt both the destination and source IP because none of that matters now because I'm sending it between devices and they can handle. In other words, it knows this is the only traffic that's going to come to it. Why do I need an IP header? Tell me who it is. I know who it is. Okay. Hey, we're coming up on the 15-minute mark.